Last video for today. Seems like a lot of videos, but they're short enough. This is about John Cockcroft and Ernest Walton, who was Ernest Walton was an Irish scientist, so they like asking about him and getting you to give his name. So you need to know what he did. So the two of them basically, what they did was they fired a proton at a lithium nucleus, and they basically turned the lithium into 2 alpha particles and energy. So let me just write down the equation first. So lithium plus a proton, lithium is 7,3, I think, yeah. Okay, plus a proton turns into helium plus energy. Okay, and we'll put that as I'll just write it as energy, or Q, okay? Now, that's 4, 2, 4, 2. So let's see, does it add up? 3 plus 1 is 4, 7 plus 1 is 8, okay? Okay, so what they did here, they artificially accelerated a proton and fired it into the lithium nucleus, effectively, and they basically detected 2 alpha particles plus energy. So that was the first splitting of a nucleus by artificially accelerated particles. Remember, you've seen it before in nuclear fission, but what you've done there is the neutrons are produced, they're not produced artificially. Okay, they occur by emission within the uranium. But in this situation, they literally fired a proton at a lithium target and managed to get 2 helium nuclei plus energy out. So the diagram of what they did, effectively, they used a hydrogen discharge tube to produce the proton. Okay, so the proton got produced here. They then had very high voltages. Okay, because the good news about a proton is a proton has a positive charge. And if a proton has a positive charge, then the proton will move towards a negative charge. So if they can they put a very high, basically this was at 400 kilovolts down to 0 volts. So the proton is seeing a far more negative place down here, so the proton accelerates down. You then have a lithium target, which is at 45 degrees. So the proton hit the lithium target, and what happened was an alpha particle, 2 alpha particles at right angles to each other are produced. They are detected by using zinc sulfide. They will make zinc sulfide glow, fluoresce, and they are noted by looking through a microscope. Obviously, you need to look on both sides at their microscope in here and here. Okay, now this is at 45 degrees because in order for conservation of momentum, then the momentum beforehand will be 0 and the momentum afterwards has to be 0. So the 2 alpha particles effectively have to come out with the same velocity in opposite directions. Okay, because remember, velocity in the opposite direction carries a minus sign. So m times v, minus m times v, when you sum them together, you get 0. Okay, so that's a zinc sulfide screen. Microscope, lithium target, microscope, and this is your very high voltage. Okay, this is your hydrogen discharge tube, which produces the protons, and the very high DC voltage that's used to accelerate the proton is generated using transformers, rectifiers and capacitors. You don't really need to know too much about that, okay? So that might be 200 kilovolts and just moving down. So the proton is kind of accelerated down. Now, when the scientists calculated the energies, now they obviously calculated the energy, the mass equivalence of the energy on the left-hand side. They calculated the energy, the mass equivalent of these two on the right-hand side. And again, they calculated the kinetic energy of the two particles. And they verified that the left-hand side was equal to the right-hand side. And that was the first verification of Einstein's E equals mc squared. That's where they verified that if you took the masses of these sides, these two, and you worked out E equals mc squared, then if you said, right, that must be the energy, if mass is equivalent to energy, that's the energy on the left. They did the same by working out the masses of these and the kinetic energies and adding them together, and they found that the left-hand side was exactly equal to the right-hand side. So it was the first verification of Einstein's E equals mc squared formula. And Cockcroft and Walton received the Nobel Prize in Physics in 1951 as a result of this experiment. Okay, it was also the first transmutation using artificially accelerated particles. So what do we mean by that? It was the first time they artificially accelerated a particle and caused an atom to turn into a different atom. Remember, that happens spontaneously during nuclear radiation and disintegration, but this was them doing it artificially. They were artificially able to turn lithium into two helium, lithium and hydrogen into two helium nuclei. So it was the first transmutation by using artificially accelerated particles, and it was also verified the first time Einstein's E equals mc squared equation was verified, and it was also the very first splitting of a nucleus using artificially accelerated particles. Okay, so I think we'll leave it there, and if you could try for homework, actually exercise 32.1, I think you have it for homework anyway, to see how that goes, and 32.2, if you could manage to do those two as well. I didn't mention it on Friday, that would be great.